Good morning, students. Myself B.K. Singh, your chemistry teacher from Oriental Public School, Kishanganj. Dear students, during last video we had discussed about solutions and various types of solutions also. That means like solid solution, liquid solution, gaseous solutions. And students, today we'll start from examples of solutions. See students, number one. Number one, sugar water solution. Yes, friend, in this solution, sugar is solute, whereas water is solvent. You know, the amount of solute is always less than solvent. Next example is friend, that is tincture of iodine. Yes, friend, tincture of iodine actually it is used as antiseptic also. And friend, tincture of iodine, it is a mixture of iodine and alcohol, where iodine is as solute and alcohol is as solvent. Next is student aerated drinks. Aerated drinks like soda water, in which actually carbon dioxide gas is dissolved in water. That means aerated drink or soda water is a mixture of carbon dioxide and water. So in this solution, students, carbon dioxide is as solute, whereas water is as solvent. Next is student air. Air is also a solution in which different components are there. These are nitrogen, you know, that is 78%. Oxygen is also there, 21%. Carbon dioxide, that is 0.03%, and other gases also. And so this is also an example of solution. Next is student copper sulfate solution. Student copper sulfate solution actually it is the mixture of copper sulfate and water, in which copper sulfate act as solute and water act as solvent, student. So and we can see little more also, like dilute hydrochloric acid. Dilute hydrochloric acid, student, actually when we mix water in hydrochloric acid, so that becomes dilute hydrochloric acid. So dilute hydrochloric acid, student, that is a combination of hydrochloric acid and water. So hydrochloric acid actually here its amount is less, because of which it acts as solute, whereas water acts as solvent. And brass, student, it is you might have known that it is an alloy, and in alloy we can say it is a mixture of zinc and copper, student, where zinc is 30% and copper is 70%. So in this way, these are some examples of solutions, and after this students will discuss the concentration of solution. Concentration of solution, students. So in concentration of solution, first of all we'll discuss the definition of concentration of solution. Students, it is a simply we can say percentage of solute. Simply the percentage of solute present in a solution is called concentration of solution, or we can also define as the amount of the solute present in a given amount of the solvent or solution is called concentration of solution. And students, concentration of solution we can find by two ways. One is mass by mass percent, another is volume by volume percent. So student, in mass by mass percent, it is a we can say the number of parts by mass of one component per 100 parts by mass of the solution is called mass by mass percent. This one is called mass by mass percent and volume by volume percent. Actually, the number of parts by volume of one component, that may be solid or solvent, per 100 parts by volume of the solution is called volume by volume percent. So these two we can become more confirm by taking two examples. So we can see one example here. First example is, see the question. From this question we will understand how can we calculate the concentration of a solution. The question is, a solution has been prepared by dissolving 5 gram of urea in 95 gram of water. What is the mass percent of urea in solution? So here, first of all, we should know the formula by which we can find out mass percent. The formula of mass percent is the mass of solute by mass of solution into 100. This is the formula. By using this formula we can find out mass percent of a solution or concentration of a solution. So here in this question we have seen that it is urea. The amount of urea is 5%, 5 gram, sorry. That means mass of the solid is 5 gram and mass of the solution is how much? It is 95 plus 5 gram, because 95 gram is water and 5 gram is urea. So including both it become 100 gram. 100 gram. So now the mass of the solution is 100 gram. So all these data putting into the formula, we can calculate the concentration of the solution. So that is first in the formula it was mass of the solid. So that is 5 gram. So we have put 5 gram and divided by mass of the solution. So divided by mass of the solution is 100 gram. So here we have put 100 gram and multiplying by 100 will get the mass percent. So here you can see each gram got cancelled and 100 got cancelled. So by cancelling 100 and gram, it become 5 only. So this 5 is the percent mass percent of the solution or the concentration of the solution. So students, in this way we can calculate the mass percent or concentration of a solution. And now students, after this we will take another example, and the question is, the question you can see here, it is first question. Let us see the question, and question is, a solution contains 5 ml of alcohol mixed with 75 ml of water. Calculate the concentration of the solution in terms of volume percent. We have discussed, we can find it out in two different ways, mass by mass percent and volume by volume percent. So here in terms of volume percent we'll have to find out. So for that one, if we want to find out the concentration of the solution in terms of volume percent, so in that case we'll have to find out, we will have one formula, and the formula is volume of solute divided by volume of solution into 100. So first let us see what is volume of solute and what is the volume of solution. So you can see here the volume of the solute, that is given 5 ml, because here alcohol is the solute. So here volume of the solute is 5 ml and the volume of solution. How we will get volume of the solution? We will have to add both, that is water and alcohol. So here alcohol is 5 ml and water is 75 ml. So including both we will get 80 ml. So now putting this data, putting this value in the formula of concentration of solution, we will get 5 ml. So here 5 ml by 80 ml into 100. So here ml got cancelled, ml got cancelled, and 10 of 80 and 10 of 100 got cancelled, and finally it is 2 5s are 10 and 2 4s are 8. So here 5 into 5 25 by 4, that is 6.25% is the concentration of the solution. So in this two way we can find out the concentration of a solution. And after this we should discuss the strength of a solution. Again, how can we find out the strength of a solution, or how it can be defined? So this is the amount of solute in grams present in 1 liter of the solution is called strength of a solution. And strength of a solution can also be found by using one formula, and the formula is, for strength, mass of solute in a gram divided by volume of solution in liter. Using this we can find out the strength of a solution. And as here mass of solute is in gram and the volume is in liter, that's why its unit will be gram per liter. So in this way, students, we can find out the strength of a solution. And after this, student, we will discuss we will discuss solubility of solute and determination of its solubility in a solution. So this one is, student, we can define first of all what is solubility of a solute. Solubility of a solute. What is solubility of a solute? So for that we can say the maximum amount of the solute which can be dissolved in 100 gram of the solvent to form a saturated solution at a given temperature is called solubility of a solute. That means here we mathematically we can describe it in this way, that to find out solubility we should know the mass of the solute and mass of solvent, and then mass of solute divided by mass of solvent into 100 will give us the solubility of the solute in a particular solution. And after this, student will discuss next is effect of temperature on solubility of a salt in water. So here, student, effect of temperature depends upon the heat energy changes which accompany the process, and here change of energy can take place in two ways. First, if student, heat energy is needed or absorbed in the process, it is of endothermic nature. And another is, if heat energy is evolved or released in the process, it is exothermic in nature. That means effect depends on which type of dissolution process is there, whether it is endothermic or it is exothermic. So it depends on these two things. In case of endothermic dissolution process, on increasing temperature the solubility will increase, but in case of exothermic, the on increasing temperature the solubility will decrease. So thank you, student, for watching this video, and in our next video we will discuss further. Okay, stay home, stay safe.